Hi, I'm Sosuke from Georgia. I'm presenting hydro-optical thermal feedback on behalf of my co-authors Masa, Shinny, and Nora from Georgia Tech, Tokyo, and Kyushu. Here, you have an LED and cold water tank. And if you put your hand in the water and turn on the LED light, you feel warmth, even though your hand is actually in the cold water. And when you turn off the LED, you feel the original coolness of the cold water. And this is our method we propose today, hydro-optical thermal feedback. And let me talk about the motivation first. Well, actually, let me ask one question first. Did you touch water today? Raise your hand. Don't be shy. I can tell who is not listening to my talk today, I guess. Water experience is very compelling, and it's in everyday life, like everywhere. And of course, even in HCI it's compelling, but it's a little underexplored. Yamashita did some visual, like immersive visual feedback underwater. This is really cool. Hand-did groundwater flow thing. But come on, like temperature is like one of the most important components of the water. So I do temperature. I make water temperature interactive. How can we change water temperature? There are three main modes in thermal feedback. The first one is simply changing the temperature of the material you're touching, like Peltier, amazing work. And you can also directly warm up the skin temperature, warm up the skin using infrared, like electric stove. Or you can directly stimulate the receptor, thermal receptors, which is basically the skin's the temperature sensor in your skin, using chemicals or electrical stimulation. But I don't think the last one is suitable for changing water temperature, because you need to change the entire chemicals surrounding your skin underwater. It doesn't sound feasible. So I focus on the first two, changing the actual water temperature or using infrared. But changing water temperature takes time. It's not very interactive. And it doesn't transmit infrared. They just absorb infrared. So it takes just too much time. So instead of doing that, I keep the water temperature constant, and I use visible lights instead of infrared rays, because water is transparent. They transmit visible lights really well. So this is my method. When your hand is in water, you usually feel it's cold because the water is absorbing your heat. But if you provide enough heat through visible lights, then you actually feel warmth, even in a cold water. This is magical. We did some psychophysical studies. We did 4, but I will only introduce 2 because I have too much. Let's do a quick quiz. Which color works better? Who do you think orange color works? Orange light warms up your skin better? How about white? How about green? Okay, I saw someone. How about blue? Okay, just 1 or 2 hands. Actually, the white and blue lights works much better than the orange and green. And I showed this through skin temperature measurement and also subjective ratings. So even like on both physical and perceptual levels, these two works much better than the others. Let me show you the skin temperature measurement. The water temperature is constant because it's not absorbing visible light like way too much. And the green is kind of underperforming. The other ones are better, but the blue and white are performing much better. How about subjective ratings? Well, this is like very consistent with the temperature measurement. So in study 1, I showed it actually works. People feel warmth in cold water. And the blue lights and white lights works better than the others. And I will skip 2 studies here. The first one, it's kind of intuitive. If it's brighter, it's warmer. And the reaction time, 1.5 seconds, which sounds a little slow, but it's pretty good for interactive systems, honestly, because it takes some time for the user to realize the warmth. and then actually the hand, the finger to press the keyboard. And another study to skip, if you use multiple LEDs, you can smoothly move the warmth on the skin, like this. But wait a second, in these studies, I only applied light on the palm, so the backside is still cold. And actually, most of the users told me that the warmth, they felt the warmth on the palm, but not on the backside. So they don't feel like the water temperature is actually changing. They just felt warmth on the palm in the cold water. So I was like, okay, study 4. I shine the skin on the entire, shine the light on the entire skin underwater. And we investigate if it's actually causing the water temperature illusion, like changing water temperature, not just warmth in the cold water. And I put many LEDs around the cold water, and I also prepared a reference water to compare the water temperature between them. And if the participant says the reference water is warmer, then I will decrease the temperature by 1 degree. I keep repeating it. And when he says it's cooler, then I will raise the water temperature of the reference. And if you repeat this, you can kind of guess the actual water temperature the user is perceiving on the hydro-optical one, the light one. And this is the result. It shows 25 degrees water plus 1200 watts, which is a little too much, but anyway, 38 degrees water. So we can actually change the water temperature perception by 13 degrees if you use like this much energy. And applications, of course, we now have the interactive water temperature. So let's move from cold water to hot spring instantly. And this is my favorite one. So even if you guys are in the same water body, like a single water body, if one of the person is using lights around the feet, they can feel different water temperature in a same water body. And of course, we have some limitations. The first limitation, we only have passive cooling, which is like turning off the lights. So we cannot actively provide coolness without preheating the skin. And we use water tank, so you cannot use like you cannot make it wearables. It's kind of hard. And as the surrounding water is keep absorbing your skin, the heat from your skin, it raises its temperature slightly, but you can make it slower if you use like a bigger water tank. So our contribution, the concept of hydro-optical, and 4 psychophysical studies showing its characteristics, and applications and some design considerations. Like we are using like very strong lights, so you don't want to like see it directly. You want to like wear HMD or a VR headset to cover your eyes, or if you don't want to wear HMDs, you can just use enclosures around the display. And that's it. Thank you so much.
Okay, you have a question.
Hi, Alex from UChicago. This is super cool work. No pun intended, I'm sorry. I have a question. So with a lot of the time, like when you put your hand into something like a cold water tank and you don't move it for a very long time, like sort of a boundary layer forms at the surface of the skin, and you get used to the temperature, but as soon as you move your hand, that boundary layer breaks apart and it feels cold again. Do you experience the same effect here? Like how much interference is there from like the actual cold water around the hand?
That is an amazing point. Yeah, almost all the users experience that. So even if you like surround your hand using like 12 LEDs, if you move your hand in the water, then the illusion like stops, like basically. So you can feel like kind of you can feel the cold water basically, like especially like between your fingers, because that's like, you know, the water vapor stays higher around your fingers.
I see. Okay, that makes sense.
So that's our future work. Yeah.
Hi, Sosuke. It's amazing work. So I just curious about that. So you use basically it's like radiations to like hitting on surface of the skin. So since like you like get like light source and the media is water, I wonder if you have like any studies on like media itself. If like water, we put some like other minerals or something into it, will that also like change like the absorption rates of all those like light?
Sorry, can you repeat it?
Yeah,
again?
so like in the waters, if we just add some like other like minerals or some things, will that like also change like the absorption rates of all those rates?
So it should change the absorption rate. So obvious next step, for example, you can put like chemicals in the water, but in that case, you need to also like measure the absorption rate of that, like the solution. Otherwise, you know, it should be different from the pure water. For this experiment, we use like tap water. So.
Yeah, thanks.
Thank you.
Junichiro from the University of Maryland. Cool work. So I believe this is the physiological response. Is that correct? Because you are blindfolded. The users are blindfolded during the user study.
Yeah,
right?
yeah.
But I believe there is a strong association between the color and the perceived warmth and the coolness. So do you have any thoughts on this kind of interaction between the physiological response and cognitive response?
You're talking about the experiments, or?
Yeah, for instance, you chose the color blue and whitish by excluding the warm color, which might influence more perceptions.
So for the user studies, the participants are all blindfolded, so it shouldn't be any associations affecting the results. But for the applications, maybe like we should consider that. And for example, like, I mean, they should feel a little different if you see like blue lights, like, you know, shining the footbath, and versus like warm white lights surrounding the footbath. So yeah.
If you have more questions, feel free to stick around at the poster session.